So in this video, I will be demonstrating how to do binomial expansion by using Pascal's triangle. So for those of you who don't know, Pascal's triangle is a triangular array of binomial coefficients beginning with 1. And it's a sequence of numbers. I'll show you what that looks like right now. So you begin with 1, and you add the terms above the 1. So to the right of the 1 we have a 0, or an imaginary number, and to the left of 1 we have a 0. So 1 plus 0 is 1, 1 plus 0 is 1, and we just work our way down using the same sequence. 1 plus 0 is 1, 1 plus 1 is 2, 1 plus 0 is 1. Keep moving down. 1 plus 2 is 3, 1 plus 2 is 3, 1 plus 0 is 1, 1 plus 0 is 1. Keep moving down until we get a good sized triangle. 1, 4, 6, 6, 1, 1, 5, 10. Oh, sorry, that should be a 4. 10, 5, 1, 1, 6, 15, 20, 15, 6, 1. And you get the idea. Now each layer in the triangle represents the coefficient used in binomial expansion. So we start with 0. Our top layer has a 0 coefficient. Our second layer has a 1, 2, 3, 4, 5, 6, all the way down until how in depth in the triangle you want to go. So let's actually have a look at some binomial expansion questions. We'll start with a very simple example of x plus y to the power of 4. Now, to do binomial expansion, you use the highest degree of the first digit, or the first term, x to the 4, and then you add one less than the first term, so x3, and one addition of the second term, so y1, and you keep following this rule until you find yourself in a loop with both the terms. So we subtract 2 from 3, we get x2, we add 1 to y squared, then we do this again. We subtract 1 from 2, x, we add 1 to y3, and then we get 1 subtract 0, which is just 0, which gives us 1 for x, and a value of y4. So this is what it looks like to expand out the digits. Now take notice that there are no coefficients for each of these terms. We use Pascal's triangle, which we have right here, to give us the coefficient of each term. So we know that the degree of what we're trying to expand is 4, so we use the 4th row in Pascal's triangle. So we know that the coefficient of each term is subject to each number in Pascal's triangle. So for example, this would get a 1, this would get a 4, this would get a 6, this would get a 4, and this would also get a 1. Now let's have a look at a bit more of a higher degree. Let's say we have x plus y to the power of 6. So we do the same thing we did before. We start with the highest degree of the first term, x to the power of 6. Then we subtract 1, x to the power of 5, and add 1 to the second term. And we keep doing this until we find ourselves in a loop. Just like that. Now we know that what we're trying to expand is to the power of 6, so we use the 6th layer in Pascal's triangle, which is 1, 6, 15, 20, 15, 6, and 1. So we bring those terms in front as coefficients to each one of our terms. So 1, 6, 15, 20, 15, 6, and 1, just like that. All right, now let's have a look at a bit more of a difficult term to expand. Let's say we have a term that looks like s plus 4t to the power of 6. The same rules apply as before, but instead of x and y, we're going to treat s as x and 4t as y. So the same thing applies as before. So we're going to do s to the power of 6 plus s to the 5 times 4t, the whole term, to the 1, plus s to the 4 times 4t to the 2. We just keep doing this until we run out of exponents. Now, same as before, we're going to use Pascal's triangle to expand out the coefficients we need for each term. So this term will have a coefficient of 1, this one will have a coefficient of 6, so on and so forth. 15, 20, 15, 6, and 1. Now you may choose to expand out the terms in the bracket that are under the exponent and just bring it in front of the coefficient. That is a stylistic choice and it is not necessary. Now I have some practice examples that you guys can work on at home. I'll put the answer to these questions in the description, and if you have any questions, just leave them in the comment section below.